Hi guys, in this video we're going to have a look at trigonometry. More specifically, we're going to find some missing lengths. So this is very similar to Pythagoras in the fact that it only works for right angle triangles. The difference is that we actually have an angle. So with Pythagoras we had two sides to find the other side. With trigonometry we need one side and one angle, and then we can work out another side. To do that, we need to be able to label the right angle triangle. And this bit is crucial because if you get this bit wrong, no matter if you do everything else right, you'll get the wrong answer. And obviously for the triangle, there are three sides. The first one is really easy. It's always the longest side and it's always opposite the right angle. So you can see here the little square, that means it's a right angle. So opposite the right angle, and the longest side is called the hypotenuse, and that's always the case. The other two sides are different and they depend on the angle. You might notice this little symbol here, it's the Greek letter theta, and that just represents an angle. So if the angle is here, this side which is opposite the angle, funny enough, we call the opposite. And this side here which is next to the angle, we call the adjacent. So opposite the angle, and this one here, the adjacent, is next to, but the other way of remembering it is that the adjacent is always in between the two angles. Okay, so that's what you need to be able to do, is label the triangle. So what if you're given this angle? So I'm just going to move theta from there to there. So what happens when it comes to labeling the triangle? Well, the hypotenuse is still the hypotenuse, it's still the longest side, and it's still opposite the right angle. However, the opposite side is now this one. This side here is opposite the angle, and this side here is the adjacent because it's next to that angle or it's in between the two angles. So that's how you label the right angle triangle ready for trigonometry. The next thing that you need to know or remember is SOHCAHTOA. And this helps us fill in these triangles here, which I'll come on to in a minute. Now, some people remember SOHCAHTOA. Other people might need little tricks or little rhymes or sentences or something to help them remember. So I've got two here for you. So skiers on holiday can always have the occasional accident. Or the other one that you could use is sun on head causes a headache, take one aspirin. So it doesn't matter how you remember it, but you must remember those because they relate to these triangles here, which you need to know or use, I should say, to help you with your trigonometry. Now, the O in this case represents the opposite, the H represents the hypotenuse, A for the adjacent, H for the hypotenuse, O for opposite, and A for the adjacent. However, the S, C, and T, and you may have noticed on the calculator before, represent sine, cos, and tan, or sin, cos, and tan. Okay, and these are the functions or the buttons that we're going to be using on our calculators when we're doing some trigonometry. So the S stands for sine, and it's theta, sine theta. Theta is just the angle that you use. And then we have O, which we said was the opposite, and then we have H, which is the hypotenuse. C is for cos theta, again theta is just the angle, and then we have the adjacent and the hypotenuse, and the last one we have tan theta, and it was the opposite and then the adjacent. Okay, and you need to be able to replicate this, you need to be able to remember this. That's why people remember SOHCAHTOA, because then they can quickly just draw these triangles, and we're now going to use them. Okay, but you must remember those things, how to label and SOHCAHTOA. Okay, so let's get cracking then and have a go at some questions. Right, so here's three right angle triangles. We're going to start with this one. So you do not label all three sides. You might notice we've been given one side and I need to work out what this side is here. So you only label those two sides, the side you've been given and the side that you want to work out. So let's get practicing with our labeling. There's the 90 degrees, this is the longest side, that's the hypotenuse. This side here is in between the two angles, it's next to that one, so that is the adjacent. Now, when we go back to our three triangles, which one has the adjacent and the hypotenuse? It's this one here. This one has the opposite and hypotenuse. This one has the opposite and adjacent. The only triangle that has the adjacent and the hypotenuse is this one. So that's the one I'm going to use. So I'm just going to quickly sketch that. Obviously, if you have it next to you, brilliant. But in the exam, you'll probably have to do a quick sketch. So cos theta, adjacent, hypotenuse. How does that help us? Well, if I'm after the adjacent, what I do is I cover up the adjacent, and this tells me I need to do cos theta times the hypotenuse. So I'm just going to write that out as well. So the adjacent equals cos theta times by the hypotenuse. It just tells you what your calculation is. So now we can substitute in the values. Well, cos is obviously just cos. Theta, remember, is the angle, which is 38. Now, when you type that into your calculator, it will open a bracket, but you must close it. So once you've typed in the angle, you must close the bracket. And I'll show you that in a minute on my calculator, and then times 15. So let's have a go. So I've got my cos. Notice it opens a bracket. 38, I'm going to close the bracket, and then times 15, and I get 11.8201, etc., etc., etc. Now the question might ask you to round it to one significant figure, two significant figures, two decimal places, whatever it is. Obviously, whatever it asks you to round it to, make sure you round it. I'm just going to stick with one decimal place, in which case I'm looking at the 8. 2 tells me to round down, so it'll be 11.8. I've used A here to just represent the adjacent, but obviously it is the value x. And of course the units are centimetres because there's centimetres there. Okay, that's the first one. Let's have a go at the second one. So I'm going to label my two sides, this one here and this one here. Hypotenuse, longer side, opposite the 90, so I've got the hypotenuse. And this side is opposite the angle, so I have the hypotenuse and the opposite. Going back to my three triangles, I'm going to use this one here because it has the opposite and the hypotenuse. So I'm just going to do a very quick sketch of that to help me. I'll do it a bit bigger this time. Which is sine theta OH. I'm after the opposite because x is the opposite. So I'm going to cover up the opposite. And that's going to tell me that to get the opposite, I need to do sine theta times by the hypotenuse. So then we can substitute those values in. Sine theta is just the angle, in its case is 67. Don't forget to close that bracket. And then 21. Instead of calling it O, I'm just going to call it X now. So let's type that into our calculator. So sine 67, close that bracket, times 21. And I have, I'm just going to move that there, 19.33060, etc., etc. And again, I'm going to round that to one decimal place. So the 3 there, and the next 3 tells me I need to round down. So 19.3 centimetres. And last one on this page, exactly the same thing. Label the two that you want. 90 degrees opposite long length there. So this must be the hypotenuse. As I said, that's the easiest one to spot. This one here is in between the two angles. So it's next to the 15 as well. So that's the adjacent. So it's the same triangle here we're going to use, because we've got the adjacent and the hypotenuse. So let's use it. This time I want the hypotenuse. So I'm going to cover that up. And that tells me I'm going to do the adjacent divided by cos. So the hypotenuse is the adjacent divided by cos theta. So let's type that in. Well, the hypotenuse is x. I'm just going to go straight into using x. The adjacent is 18. I'm going to divide that by cos theta. Theta is just the angle, which in this case is 15. So let's type that in. 18 divided by cos 15. Close the bracket and press the SD button to get what it is as a decimal. So 18.634 9 blah 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 blah, and to one decimal place 6 is the 1 decimal place, 3 tells me to round down, so 18.6 centimetres. Excellent. Okay, 3 more examples then, just to really nail this home, and I'm going to have a look at some trickier problems. Okie dokie, here we go then. So, same thing, label the 2 sides. There's my angle. This time I have the adjacent in between the 2 angles, and I have the side that's opposite that. So this is the tan triangle. So tan theta, opposite, and the adjacent. I want the opposite, so I'm going to cover that over. So the opposite equals, oh, I haven't put my theta in. Tan theta times by the adjacent. So the opposite we had was x, which is just there. Tan, the angle is 8, close that bracket. And then we have times by 11. So let's type that in, see what we have. Tan 8, close the bracket, times 11. We have 1.5459, etc., etc. So 1 decimal place then. 4 tells us to round down. 1.5 centimetres. Excellent. Next one, again, label the 2 sides. So the angle is here. This side is in between those 2, so that's the adjacent. This side here is opposite the angle, so that's the opposite. So again, I'm going to be using this one here, the adjacent and the opposite. Slight difference though, this time I want the adjacent, so I'm going to cover that up. So the adjacent equals the opposite, this time divided by tan theta. So let's substitute in what we have. The adjacent is x, and that equals the opposite, which is 8, divided by tan, and the angle is 31. So let's type that in, see what we get. 8 divided by tan 31, close that bracket, and we have 13.31423 blah 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 blah. And again, I'm going to do this to 1 decimal place. 3 is the 1 decimal place. 1 tells you to round down. 13.3 centimetres. Excellent. And the last one for this page. There's the angle. This side is opposite it, so I've got the opposite. And again, I've got the longest side here, opposite the 90 degrees. So I have the hypotenuse, and that's going to give me my, or tell me to use my sine triangle, opposite and hypotenuse. So sine theta, opposite, hypotenuse. I want the hypotenuse, so I need to do the opposite divided by sine theta. So hypotenuse equals opposite divided by sine theta. The hypotenuse is x in this case, it's our missing value. Opposite is 10 divided by sine, and the angle is 52. So I'm going to write that down, just extend that slightly. And I'm going to type it in, 10 divided by sine 52, close the bracket, press the old equals, and we have 12.6901 blah 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 blah. And to 1 decimal place I have 6, 9 tells me to round up, so this one actually is 12.7 centimetres. Okay, so there's all the questions that could be asked to do with trig and all the different ways they can be asked. So let's have a look at some wordy examples then, make it a little bit more interesting. So this one here is similar to, in fact, I think it's the same as far as the idea of the question. I need to work out the area of this triangle here. Now, to work out the area of a triangle, we do base times the height. So the first thing I'm going to do is draw the height in. And in doing so, I've just made a right angle triangle, which means I can use Pythagoras or trigonometry. Now, I can't use Pythagoras in this case because I don't have 2 lengths. I only have this length here, and I have the angle there. So it's definitely going to be a trig question. So it's probably a good idea just to draw a very quick sketch of this triangle here, just to avoid any confusion. So I know that's 35. I need to work out that, which is the height, call it H. And if the whole thing there is 20 and it's an isosceles triangle, that would mean that this side is 10. Now don't let the H confuse you. Obviously that's H for height, not H for the hypotenuse. So you might want to use a different one there. You could use X again, it's entirely up to you, but don't let that confuse you. Label our two sides. Well, if there's the angle, this side is opposite, so that is the opposite side. And there's my right angle, and this side here is in between the two angles. That must be the adjacent, which tells me that I'm going to be using my tan theta opposite and the adjacent. I want the opposite, so I'm going to be doing tan theta times the adjacent. So the opposite we called H for height, so the height will equal tan theta, and the angle was 35, what's there, times by the adjacent, which is 10. So the height in this case, let's have a look, tan 35 times by 10 is 7.00207 blah 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 blah. So to one decimal place, really nice and easy, 7.0 or just 7 is going to be what I'm going to use as the height, so centimetres. So now we can go back to the question. Don't forget to go back to the question. It was, what is the area of the triangle? Well, the base of the triangle is 20 times by the height, which we just worked out was 7.0, which is 7, and we divide that by 2. So 20 times 7 is obviously 140 divided by 2 is 70, but let's just double check it just in case. There's no point trying to guess these things if you're in the exam. Just doubly make sure, yeah, we were right. So 70 centimetres squared because it's area. Okay, two more. This one here, very, very, very common. They love the old ladder against the wall question. So here we go then. How high is the ladder up the wall? So here's my wall, here's my ladder, here's my man supposedly floating, although he should be on the ladder. And we're told it's 2 meters away from it, and we have the angle there of 65 degrees. So same thing, I'm just going to use trig. I'm going to label the side. I want to know what this side is. Let's call it the height again of the ladder. I've been given this length here. So this length here is in between the two angles, so that's the adjacent. And this length here is opposite. So again, I'm going to be using the tan one here. And again, I want the opposite. So I'm just going to be doing tan theta times A again. So tan theta, which is 65, times by the adjacent, which is 2. Let's see what that gets us. Tan 65, close the bracket, times 2, and that comes out at 4.2890, etc., etc. So the one decimal place, the 8 will round the 2 up to be 4.3 centimetres. Of course, what they could have asked is, what is the length of the ladder? In which case, exactly the same thing. This side will still be the adjacent, but the ladder will be the hypotenuse, in which case you'll have the adjacent and the hypotenuse, which means we'll be using the old cos. So cos theta A and H, and if you want the hypotenuse, we'll be doing the adjacent divided by cos theta, so it would be 2 divided by cos 65. So what would the length of the ladder be? 2 divided by cos 65. So the ladder is 4.73, etc., etc. It's meters. So I put centimeters there, didn't I? So sorry, it's meters. Meters long. Okay, so it's not part of the question, but it's just something that could crop up. And the last one. Love this question. How far away is the bird from Mr. McKelvey? So here's Mr. McKelvey, and he's looking at the bird up in the tree, and we made it a bit basic by having a right angle triangle here. So he's 8 meters away from the bottom of the tree, and he's looking up at an angle of 54 degrees, and I want to know how far away the bird is. So from him to the bird, I'm called that X. So exactly the same thing, label the sides we've been given. So I have the side that's in between the right angle and the angle, so that is the adjacent, and I have the longest side, which is opposite the 90, which is the hypotenuse, which again is my cos. This time I want the hypotenuse, it's the same as this one, so yeah, this time I want the hypotenuse, so it's the adjacent divided by the cos. So hypotenuse equals the adjacent divided by cos theta. I've got a bit of space, I can write that. The hypotenuse in this case is x, and that equals the adjacent, which is 8, divided by cos, and the angle is 54. So let's type that in and see how far away this bird is. Cos 54, close that bracket, is 13.610, etc., etc. So to one decimal place, one tells you to round down, is 13.6, and it's meters, yeah. So the bird is 13.6 meters away. So hopefully there's just a few different ways that you can use trigonometry in some more slightly complicated questions. Hopefully that's enough examples to really get that across. Label your sides, so make sure you're using the right sine, cos or tan triangle. And once you've done that, just be careful to close the bracket, and then obviously careful with your rounding at the end. Hopefully that helps, guys. Thanks for watching.